You're listening to the Anesthesia Patient Safety Podcast, the official podcast of the Anesthesia Patient Safety Foundation. We're bringing you the very best from the APSF newsletter and website, as well as the latest information in perioperative patient safety. Thanks for joining us.
Hello, and welcome back to the Anesthesia Patient Safety Podcast. My name is Alli Bechtel, and I'm your host. Thank you for joining us for another show. We are talking about advanced medical technology today and how to incorporate a very special type of device into your practice. Before we dive into the episode today, we'd like to recognize Neon Codon America, a major corporate supporter of APSF. Neon Codon America has generously provided unrestricted support to further our vision that no one shall be harmed by anesthesia care. Thank you, Neon Codon America. We wouldn't be able to do all that we do without you. You might be thinking that I was a little vague and that there are several devices that we could be talking about on this podcast. But if you listened to the podcast last week, then you know that today we are continuing our discussion on quantitative neuromuscular monitoring. Let's get right back into our featured article, Advancements in Quantitative Neuromuscular Monitoring by Ross Renew. To follow along with us, head over to apsf.org and click on the newsletter heading. Fifth one down is Newsletter Archives. Then scroll down to October 2021. From here, scroll down looking in the right-hand column until you see our featured article. And I will include a link in the show notes as well. Last week, we talked about a call for high-quality, real-time, reliable, and accessible quantitative neuromuscular monitoring that is at the same standard as our monitoring for blood pressure and oxygenation and ventilation. We also reviewed barriers to improved neuromuscular monitoring, including lack of knowledge, overconfidence, inconsistent training, and lack of easy access to and easy-to-use, reliable quantitative neuromuscular monitors. Plus, we talked about peripheral nerve stimulators, mechanomyography, and acceleromyography. The next device that we are going to review is kinesiomyography, or KMG. This monitor utilizes a piezoelectric sensor placed in the groove between the thumb and the index finger, with a handy diagram on the sensor as a reminder for the correct positioning, along with standard ECG electrodes placed over the ulnar nerve. During monitoring, the ulnar nerve is stimulated, leading to adductor pollicis muscle contraction and bending of the sensor, which then informs the objective measurements of neuromuscular function. The KMG device has a built-in preload device in the form of the piezoelectric sensor, and reverse fade phenomenon does not occur, which is good news. On the other hand, when compared to mechanomyography, the gold standard, there are wide limits of agreement. Another consideration with this device is the positioning of the hand to allow freedom of movement for the thumb and patient movement during emergence, which can lead to unreliable results. You can find the KMG device available only with incorporation into the anesthesia workstation. Have you used a KMG device? I used one in the operating theater today. Check out Figure 2 in the article for a picture of this device. Now, our next device comes highly recommended all the way up to perhaps the new gold standard, since it agrees closely with mechanomyography, and it has been around the longest. It is electromyography, or EMG, which provides reliable quantitative measurements and does so even when the arms are tucked. Plus, there are newer devices utilizing this technology, so you may see this in an operating room near you soon. It is able to do this by measuring combined muscle action potentials across the neuromuscular unit. It does not use motion to quantify neuromuscular strength and function. Instead, EMG measures the amplitude of the combined muscle action potentials, which is directly proportional to the number of activated muscle fibers and the force of contraction. Now, there are some considerations with this device, since there may be interference from electrocautery. In addition, changes in skin temperature can affect the results. The combined muscle action potential's amplitude may increase by 2 to 3% for every 1 degree Celsius decrease in skin temperature. EMG devices can be found as a portable unit or as part of the anesthesia workstation and often require proprietary electrodes to stimulate and measure the combined muscle action potentials in the hand, although the foot may also be used. Let's take a closer look at how it works. The device may be positioned on the hand with ulnar stimulation. There are 3 muscle groups that may be used to determine the combined muscle action potentials, including the adductor pollicis muscle, the first dorsal interosseous muscle, and the adductor digiti minimi. Check out Figure 3 in the article for a picture of this device. We have one more exciting monitor to discuss. It is cuff-based monitoring. That's right, a new device has been created which combines the non-invasive blood pressure cuff with neurostimulation to provide a quantitative measurement of neuromuscular function. The first step is inflating the cuff to about 60 millimeters of mercury, and then electrodes within the cuff are activated to provide neurostimulation. When muscle contraction occurs, this leads to pressure changes in the cuff, which serves as a measure of neuromuscular blockade. Considerations with this device include placement of the cuff on the upper arm compared to the distal arm or leg can lead to changes in the neuromuscular properties and measurements. In addition, it is not interchangeable with EMG or acceleromyography-based monitors. The device may need to be studied further to determine the reliability of this technology, but it is exciting and we are looking forward to hearing more about this in the future. Now that we have reviewed the technology, we need to discuss how anesthesia professionals can use quantitative monitors of neuromuscular function when providing anesthesia care to help keep patients safe. First, it is time to evaluate your practice and knowledge base as well as the culture in your group. Do you already have an understanding of the threat to patient safety that is postoperative residual weakness? And do you already use quantitative neuromuscular monitoring? If so, great job! If this is not part of your practice currently, what are the barriers to implementing this new technology into your workflow? This may involve further education, time, money, and training. Renew points out in the article that the time required to set up and use a quantitative neuromuscular monitor adds only about 19 seconds on to the start of the case. That's 19 seconds of time for a significant increase in patient safety. Culture change within an anesthesia group may be another barrier for routine use of this newer technology. Let's take a look at the article by Todd and colleagues, The Implementation of Quantitative Electromyographic Neuromuscular Monitoring in an Academic Anesthesia Department, from Anesthesia and Analgesia, published in 2014. The authors report about the concern for patient safety related to management of neuromuscular blockade after finding about 2 to 4 reintubations each year in the PACU that were likely related to inadequate reversal. Following this, the Datex Omida electrosensor EMG system was placed in each operating room along with an educational initiative. However, use of these devices were not routine at less than 50% of the cases when neuromuscular blocking drugs were administered. Thus, the culture change in this department did not occur at first. The next step involved performing 5 sampling surveys and sharing the results with the anesthesia department. The surveys involved checking train of 4 in the recovery room for extubated patients who received non-depolarizing neuromuscular blockers, as well as a sample of patients who did not receive non-depolarizing neuromuscular blockers. You may not be surprised by the results of the first survey, which had 31% of patients with a train of 4 ratio of less than 0.9, including 17% with a ratio of less than 0.8 and 4% with less than 0.5. And the quantitative monitor was only used in 51% of patients, and 23% of patients did not have any reported monitoring at all. Over the next 2 years, there were significant improvements in this department, with increased use of quantitative monitoring up to 83% of cases in patients who received a non-depolarizing neuromuscular blocker, with down to 15% of patients with a train of 4 ratio less than or equal to 0.9 and only 5% less than or equal to 0.8. The biggest win for patient safety was that over the last 2 years of the study, there were no reintubations required in the PACU related to inadequate reversal. In 2015, Todd and colleagues provided some additional feedback about neuromuscular monitoring and respiratory complications in the PACU. After publication of their first article, the authors report on 2 cases of reintubation in the PACU related to the use of non-depolarizing neuromuscular blockers and inadequate reversal. The first case was a patient who had no documented neuromuscular monitoring during the case and arrived to the PACU in respiratory distress, required emergent reintubation, and had demonstrated fade on qualitative twitch monitoring. The second case was a patient who had only qualitative train of 4 monitoring during the case, with 4 out of 4 twitches measured at the orbicularis oculi muscle prior to extubation. The patient's oxygen saturation was 60% upon arrival to the PACU. Emergent reintubation was performed, and quantitative neuromuscular monitoring revealed only 2 out of 4 twitches. The authors highlight the following threats to patient safety: failing to monitor, and using qualitative monitoring only. And this is when the advanced neuromuscular monitoring technology is readily available. These cases and so many cases like this continue to reveal that neuromuscular monitoring is essential every time non-depolarizing neuromuscular blocking drugs are administered. And the type of monitor is just as important to keep patients safe. Qualitative monitoring alone is not enough to demonstrate adequate reversal and intact neuromuscular function, especially when quantitative monitors are readily available. Now, the authors do point out that quantitative monitors require training to be able to use, troubleshoot, and distinguish artifact during routine use. I will include the citations for both of these articles in the show notes. If we return to the APSF article by Renew, he leaves us with a call to action that I'm going to read now. Becoming familiar with emerging monitoring technologies will certainly improve the chances for successful implementation and changing practice. The specific monitor or modality is just one part of the change, as the decision to change practice is much more important and oftentimes is far more challenging. This change will undoubtedly require additional work. However, we owe it to our patients to deliver state-of-the-art care. Now, before we wrap up for today, we are going to hear from Renew once again. I asked him, what do you envision for the future related to neuromuscular monitoring? Let's take a listen to what he had to say.
Well, I think it's an exciting time to get interested and involved in research in this field, and there's a lot of interesting things that are coming to market now, interesting devices. I also think that we're going to see a expansion of guidelines and practice parameters that mandate the utilization of such devices. A number of anesthesia societies have already incorporated the use of quantitative neuromuscular monitoring into their practice parameters and guidelines. And I think that's only going to continue to expand, particularly here in the United States. Ultimately, I see in the future adoption of these devices really whenever neuromuscular blocking agents are administered to the patient, whether it's in the perioperative setting or in the critical care setting. These drugs have potential to do significant harm to patients, and utilization of monitors such as these really provide us with useful feedback and information so that we can determine accurately the level of blockade of our patients at that time.
Thank you so much to Renew for his contributions to the show today. We are looking forward to learning more about newer devices in the future and expanded, routine use of advanced neuromuscular monitoring to keep patients safe going forward. If you have any questions or comments from today's show, please email us at podcast@apsf.org. Please keep in mind that the information in this show is provided for informational purposes only and does not constitute medical or legal advice. We hope that you will visit apsf.org for detailed information and check out the show notes for links to all the topics we discussed today. Have you checked out the newest page on the APSF website? It is the Lookalike Drug Vials, Latest Stories, and Gallery. I will include a link in the show notes, and we hope that you will head over there to read about the latest alerts, check out the gallery of lookalike vials, read the related APSF articles, listen to the related APSF podcasts, and consider submitting your own lookalike drug alert. You can help to share information and keep patients safe. Until next time, stay vigilant so that no one shall be harmed by anesthesia care.